at a company called Tiny, and I'm going to be telling you today about a project we did about a year ago where we ported over 100k lines of code to TypeScript. I'm just going to go through, at first, about Tiny, the company, and a bit about myself, and then I'll just jump straight into the project. The motivation behind it, why we chose TypeScript, how we converted JavaScript to TypeScript, and then the benefits, the lessons learned, and some of the ongoing work we have. If you take nothing else from this talk, types help, but in particular, gradual typing really helps. So Tiny, we make a text editor called TinyMCE, which is a popular open source project. It's a rich text editing platform, and it's been used by companies like WordPress, Medium, Shopify, Tumblr, Atlassian, Eventbrite, and many, many more. TinyMCE itself has been around since 2004, so it predates jQuery, to give you some context. But in 2015, we actually launched a startup, and we have offices here in Palo Alto, in Australia, and in Sweden. That's what it looks like at the moment, if that jogs your memory at all. And just to give you some this idea of the scale at which we work at, we have 1 million plus users on cloud, 125,000 downloads a week, 1,000 paying customers, and 232 contributors, which can be fun to manage. All right, so myself. I'm from Brisbane, Australia. You may have noticed the accent. I started at Tiny as an intern during my Bachelor of Engineering. I was a QA intern, then I became a QA engineer, and then just over a year ago, I became a software engineer. And this is actually one of the first projects I did as part of the team as a software engineer. And fun fact, I guess, I'm an admin of the Australian community for a game called Splatoon, if anyone's ever heard of that game. So, more context. 100k lines of code. How on earth did we reach those numbers? Here's a nice little graph from OpenHub. You can see the point of conversion when we went from like 120k lines of JavaScript to a bit under that of TypeScript. TinyMCE itself is split up into a few different parts. The core of it is about 30,000 lines of code. The user interface is about another 30,000 lines. And then we have 44 free core plugins, a bunch of other premium plugins, etc. And they're roughly 40k. You'll note those don't quite add up to 112. I'm pretty sure the rest of that 10k is tests. Plus, we have various other projects and libraries. We have a couple of older editors. We have a bunch of in-house tools, test frameworks, etc. We converted everything. So 100k lines of code is actually a low estimate. Nobody wanted to actually do that math because there is just way too many things to count. So, the conversion project. Before, when we were just using JavaScript, we tried a lot of frameworks. Mostly these were module frameworks, require.js, all that kind of thing, but we tried a lot and none of them really fit us. We also use a functional programming style. Explaining functional programming is a whole nother talk. Basically, it's a programming paradigm based on math, which is easier to reason about, easier to test, and generally makes our code a little more robust. But because we do that, we ended up writing our own libraries and frameworks. This avoided a lot of problems with upgrades, it avoided problems with framework churn, it made it easier for us to fix problems because we just went in and fixed them, we didn't have to talk to anyone else. But it did mean we had to write very defensive code, which resulted in increased code size, runtime performance issues, all that kind of thing. And then ES 2015 appeared. So some of the ES 2015 features, particularly standard module system, but also things like arrow functions, were very enticing to us. So we decided that, well, in 2017, when it was becoming more widely adopted, we decided we should convert our code. We had also, for a while, been talking about switching to an alternate JavaScript language. And we figured if we were going to do one conversion, we might as well do both at the same time. And our wish list for language features for this conversion was static typing, because that would give us compile time checking, access to a bunch of tools and that kind of thing, and pattern matching, which is a functional programming concept, but basically would make sure that things like allow various switch case statements and things, we could switch them to pattern matching, regex could switch to pattern matching, and it would make our code a lot more robust. So why did we end up on TypeScript? We actually looked at ReasonML, PureScript, and TypeScript originally, and particularly in my team, where we do client-side JavaScript for the editors, we looked at how much of the functional programming feature set we actually needed, the learning curve for each language, and the upfront development cost to switch. So we tried out these languages. ReasonML, we actually used to rewrite our PowerPaste plugin. So we have a text editor. One of the things you might want to do is copy-paste content from a Word document into our editor. If anyone has ever seen Word's HTML, it is incredibly complicated and complex, and parsing it is a nightmare. And we were originally doing this with regex. And I'm sure many people here know that regexing HTML is a terrible, terrible idea, and you should never, ever do it. So we rewrote this in Reason, which gave us the ability to instead use strong types and pattern matching, which made the code a lot more robust, and the plugin is a lot better off for it. And there's a lot more we can do now that we've done that. Its syntax is also fairly similar to JavaScript, so it's easy to learn, but it is an entirely different language. We would have had to rewrite everything in Reason. So we also tried PureScript. Now we use this for some of our internal prototypes, even today still, particularly on the cloud services side. We found that side effect tracking speeds up code reviews and training, and optics, which is a functional programming concept, improve runtime efficiency. But on the client side, there is a lot of functional programming features in PureScript that we just don't need. So in the end, neither of these is an easy drop-in replacement for our current JavaScript. So we end up on TypeScript. The one big downside was it does not have pattern matching, which is really unfortunate. It would have made our jobs a lot easier. It would have made our code a lot more robust. However, we decided it was a fair trade-off for the fact that vanilla JavaScript is valid TypeScript. So we were able to reuse most of our code, just wrap it up differently, and we were done, which made the conversion very quick and very easy. That, plus the fact that we were already using a module system with strict syntax, one that we had made out ourselves, of course, but based on the AMD spec, meant that we were actually able to convert most of our code just with a script. So that, again, made less developer time, made it very easy, very quick. Of course, we got types, but in particular, we were able to do gradual typing, and this is what made the project so easy. So what is gradual typing? It's basically what it sounds like. It's the process of starting with minimal types and then adding more as you go. It requires a mix of static and dynamic types, which is exactly what TypeScript gives you. And it means that you require minimal initial work to start adding types into your project, and then you can invest as much time as you want each week, month, whatever, in then adding types to your project. And it also means you can start with really simple types, and you can increase the complexity of your types as you learn and you adjust to the language, which means there's also less upfront training time needed, because people can learn as they go. So in general, that means you have a low initial cost of adding types, and it means you have a flexible ongoing cost, which makes it really easy to add into your schedule with your sprints and everything, and also a lot easier to convince management that this is something that you should do. All right, so the how. How did we actually convert all of this code? So we use a very modular architecture for our code. We have many, many libraries. If we have something that we're reusing in a couple of different places, we put it in its own library. If we have something that has very distinct functionality, we put it in its own library. So we had to then do this conversion process for each library. And I'm guessing there's about 100, just off the top of my head. I know I converted about 50. So we had this script that we wrote, and it would do most of the conversion to ES 2015 and TypeScript, and I'll run you through that in a minute. We then had a dev manually check the script converted each file correctly. Now that sounds like a lot of work, but because we already had a module system that we were using, and it was mostly syntax changes, that was actually very quick, because it was mostly just checking the import and the export syntax had been changed over properly. We then update with changes from already converted dependencies. So because we were doing this on so many libraries, and we were doing libraries one at a time, and we were fixing problems as we went, you would convert a library, and often there would end up being like API changes for that library, So then when you go to convert the next library, and it depends on the one you just converted, you had to then update it and cascade those changes through all the libraries. So we were just keeping big lists of what we had changed and just checking that each time we were going through a library. So then we fix the problems found by TypeScript, we run the test, fix any problems there, and then just update the build process to run TSC, all that. So, conversion script. And then of course this is the fun part. How on earth do you actually write a script to do this conversion? We transpiled all the modules using an abstract syntax tree. So this is a concept from compilers and the like. An abstract syntax tree is just a data structure. It uses a tree representation of the syntax of code. And of course, once you've loaded code into that kind of tree representation, it's very easy to do all the kinds of transformations and manipulations that you need to do this. So the main things that we had to do was to change the import syntax. I'll give you an example in a minute. I've got an example diff. So just changing the import syntax over from the AMD spec to the S2015 module spec. We then pull all the code out of a wrapping function into the root level. Again, I'll show you in a minute. And then we changed the export syntax and applied export default any. Anyone who knows TypeScript here is going to say, like, you're not typing, you're not using TypeScript properly if you're using export default any, but that is part of the gradual typing process. I'll explain that in a minute as well. All right, so script would then just move all the files, rename them to TS, copy templates for all the configuration files, so your tsconfig, our build scripts, a bunch of other things, would just copy it in, change anything it needed to. We then generate a main.ts from the API folder. So we had been very strict ourselves about putting any file that other libraries should be able to touch into an API folder. And when we did this, we decided that we wanted to have a single API entry point for every library. So we generated a main.ts from the contents of that API folder. We set the main.ts as the API entry point, or main.js as the API entry point. And from then onwards, if any libraries tried to touch anything outside of that folder, they couldn't, and we got type failures. And then, of course, just updating package.json, get ignore all those files. So here's an example of our old AMD spec system. So we have this define function that is, I don't have a pointer. All right, so define function that's around the outside. We have these three lines here, which are basically, well, the first one is an explicit module name. The next two are imports, essentially. We have the import, and then we're actually passing it into the function that wraps the body of the module. And then we have this return statement here, which is basically our export statement. So from that, we were able to just turn it into this. So you can see here how we had those steps. So we have the imports just being converted into this syntax. And that was honestly probably one of the more complex parts of the script because it does have to pull all the strings out, parse them, that kind of thing. But in the end, you do end up with very nice code. This is just the body of the function. This did not change. This is this nice easy bit where you're just pulling the code out, putting it at the root level, done. There's no changes to the code there. And then, I've lost my pointer. Anyway, the return basically just got replaced with an export default any. That's all it is. All right. Of course, our script didn't actually add any types apart from that export default any. But the export default any did mean that our code compiled at that point. So at a very basic level, the conversion was done. But we did start adding types. So we started going through all our libraries, and in particular, we went through the ones that were depended on the most. We actually built a dependency tree at one point, so we had a nice graph. And we found, we have a library that is essentially our version of jQuery. And so you can imagine how many times that's depended on. So we did that first. And by doing that first, it meant that any types we created, any bugs we found, we were able to just cascade it through all the libraries that then depended on that library, and that made our lives a lot easier. We would also add types with each PR. So new code must be at least partially typed. We do everything we can. If you submit a PR without any types on it in my team, you will get yelled at. And for a fair while, the rule was if you touch a file, type it. Even if you don't change it, if you open it to track some code through it, you type it. That is now your job. And that meant that we did actually get types through these libraries fairly quickly. And we did also have a few devs sit down and take, like if we got ahead on our sprint or something, a dev would sit down for a day or two, they'd pick a library they knew well, and they'd just sit down and type it. So that also happened as well. And that means that now, year on, most of our libraries are actually partially typed. There's some that we don't touch very often that have minimal typing in them, but we have gone through at this point and removed most of the export default any's, or most of the any's, and dealt with at least the problems that come out of that. So, what are the benefits we got? Of course, we got types. That meant we gained type-based tools like find all usages and automated refactoring. Automated refactoring is amazing. I don't know how I live without it. We also, of course, got compile time type checking, which, again, amazing. It is ridiculous how many errors that found the very first time we ran TSC. Even just adding some simple types at the beginning started catching bugs, and I have a couple examples in a second. And typing our most common dependencies caught many more. There were so many places where people had used a function from another library incorrectly, or at some point we'd written code using one of those functions, and then we changed it in the dependency and not updated it in the code that was depending on it, and things were broken, but we didn't know because we weren't getting any proper errors from it, nothing was telling us. So that kind of thing got caught very early on. So a couple of quick example bugs. This one was fun. We had this constructor, we're passing in all the variables, and to make it easier to read at the time, we'd put comments with the names of each of the variables in there. Except someone forgot a comment, and we ended up with an accidental global. So in this case, this was fine, it didn't actually cause any bugs, but you can imagine if we had a variable in there somewhere actually called content, this could have overridden the value, it could have caused all kinds of problems. So this was a nice little catch. And we did this kind of commenting quite a bit before, just to make the code more readable. And this wasn't the only example of this, unfortunately. Then we have this. This is, among the team, lovingly called the case of the mysterious double argument error. So we had this function, we defined it with to take 6 arguments, and we only passed in 5. And of course, that means that shortcuts has been assigned to keyboard, smart view has been assigned to shortcuts, settings assigned to smart view, and settings is now undefined. You would think this would throw an error at some point in the however many years that this was in our code base. But it didn't, because we'd actually done this again in reverse, further down in the code. Before shortcut smart view or settings was ever used by the code, we had managed to do this again and pass 6 variables into a function that was meant to take 5, and it just kind of lined up and worked. The person who found this spent a good couple hours trying to figure out what on earth had happened, and then basically just put their head in their hands and groaned, which was quite entertaining. But that kind of thing, we think it probably came from bad manual refactoring, which of course is not a problem now that we have automated refactoring. And this is also the kind of thing that TypeScript just immediately picked up on. So this was quite a nice catch, because at some point, this could have become very, very bad. All right, so we also got gradual typing. I think I was joking last week that the alternate title for this should be gradual typing is amazing and you should do it. But gradual typing in particular saved us a lot of time and effort, because it meant that we did this initial conversion with this script and everyone just checking all the libraries, PRs, done. There weren't actually any types in there yet except for the any's, but our code compiled and people were able to get on with the dev work. So rather than having everyone locked into doing this conversion for 3 months, 6 months, whatever it would take if we were doing a full rewrite, typing everything, this took, I think, a month, and not even everyone was working on it. Some people were just still doing other stuff at the same time. We had just a few devs working on this, took a month, we hit a few issues halfway through, and we had to, change things up. But most of the team was able to just go back to normal dev really, really quickly. Like I said before, sometimes devs will take a couple of days to type a library. We have a bunch of integration libraries for integrating with various projects from companies that we work closely with. And I think all of those are completely typed at this point. It's one of our guys who usually does the integrations. He sat down, did a bunch of courses on TypeScript, learnt it ridiculously well, and then just took a couple of days for each one and just fully typed them. All the crazy, I don't even want to touch that code because I'm not as good at TypeScript as he is, and some of the things he has in there are insane, but it does mean that those integrations are now a lot more robust than they used to be. All right, again, we also had types with most PRs. When we started removing before we started removing the any's, we only had minimal errors, so it was very quick to go through those, fix those up. But then we started removing them. And we actually did quite a few libraries where we just removed all the any's in the library at once. And then sat down for a day or two and just started fixing up the bugs, started adding more types, whatever. But by doing it that way, we were able to do modules slowly and methodically, which really did save us a lot of time in the end. We also, of course, got a lot of increased readability out of it because you have types. I mean, most of this will probably be obvious to people, but types make it easier to follow the code, especially in projects like ours where we have a lot of code. We have a lot of modules. We have sometimes variables being passed through multiple files, up to a dozen files before it's actually used. Having types has made that a lot easier. In particular, having interfaces, being able to put a bunch of data into an object, have an interface for that, have it all line up, makes it a lot easier to read. Of course, they also make it easier to debug. Type errors are really, really nice, much nicer than half of the console errors you get from JavaScript. It's also sometimes much easier to match weird values to types, particularly if you have the objects of data with the interfaces. You get this crazy object and you have no idea what half the values in it are. You just go find the interface that matches, done. And it also makes it easier for new developers to get up to speed. This was the first project I did. I spent a little while on the old code before we started doing this, and we have hired new developers since we did this. And I'm pretty sure they've had a much easier time figuring out our code base than I had when I was trying to learn it. Just because they have the types, they have the interfaces, it does make it a lot more readable. So, lessons learned. This is the fun part, of course. Convert common libraries first. So I mentioned that we did this mostly. We have the modular architecture, we have many libraries, many of them depend on other libraries. I looked up the other day, one of our libraries is depended on by 40 other libraries, so you have quite a bit of interrelation there. We mostly converted them first, the most common libraries, particularly when we had that dependency tree. We were able to go through and actually work through the levels. That helped a lot. But we did do some at the same time as the first few. In particular, we did some of the integration libraries first, which is partly why there was a big blitz on them later, because there were mistakes made. We ended up with duplicate type definitions. So for example, someone had made an interface in one of the libraries to represent the types in there. We ended up with an interface in one of the integration projects that was meant to be for the same thing, but those two interfaces were actually different. So at various points, we ended up with problems with type errors, clashing code, clashing types, all kinds of things. And so we have duplicate code and we have errors because of it. So I would definitely recommend if you have this kind of modular architecture and you can build something like a dependency tree, you can at least figure out which libraries are most common. Do them first, figure out all the bugs in those, and then start working your way through. It will save you a lot of time and hassle. Gradually introduce compiler features. TypeScript has lots of nice compiler features. It has lots of nice flags for turning them on and off. We started with the most basic ones that we wanted, with the idea of gradually introducing the stricter and stricter ones that we knew would require us to rewrite code, have big discussions, all that kind of thing. But a couple of times we enabled compiler features without actually testing all the libraries first. And this is a really bad idea, as it turns out, because this breaks the build in awful ways. And most of the time we ended up with one of the two dev teams down for a whole day trying to figure this out. Because we don't like to just roll back breaking commits. We tend to try and sit there and actually figure out what happened, why it didn't work, if we can actually get it to work. In particular, we had one at one point where we turned on a compiler flag to disallow circular references for types. And it turns out one of our libraries was using those a lot. And we managed to strip out some of them, but we got down to a point where there were 2 types that were referencing each other, and there was almost no way for us to remove that circular dependency without several days' work. And we ended up having to actually turn off the compiler feature of that library, even though we fixed it in everything else. So make sure you test everything. It is really, really painful. I would not recommend doing this at all unless you have a proper way of testing every library that could possibly be affected by whatever you've just changed. Which leads me to write a script to test everything. If you can test something, put it in the script, whether that's types, linting, checking that the build works, tests, whatever, anything that you can check, put it in a script and get a script to do it for you. Run it whenever you make a big change, whether that is actually a big change in one of your libraries or whether that's a small change in a library that a lot of other things depend on. Because that is honestly what broke our code the most, was someone would just change something tiny down in one of these core libraries we have, and we just have cascading failures, particularly with the types, particularly with the interfaces. So I would definitely recommend doing this. Ours, for example, is called the really cool script, the successor to the cool script, which does changelog stuff for us. It has a list of all our libraries, just an array listing all the libraries. It clones each one, installs its dependencies, runs TSC, and then runs npm test. And for us, npm test is a script that just runs whatever tests, every single test that is in a library, it runs on npm test. We unfortunately have not been able to put linting or build checks in this yet, because TSC and npm test are the only 2 things that we have consistent across all our libraries at the moment. Linting and build, unfortunately, for a bunch of our libraries is per library. It's different for each one. But that is something we're wanting to do, is to make those more similar and get them into this test, because this has saved us a lot of time. It does take a while to run. For us, it takes almost an hour to run on all 100 or something of our libraries. We have also recently threaded it because it was taking too long and someone got bored and sick of it. But sitting down and running this has saved us many, many times, because it doesn't stop on a failure. It will log a failure and then it keeps going through its libraries. So you let it run, you come back to your computer and you have a list of all your problems and you can just start working through them. And I mean, it takes an hour, but someone just sets it running and then we go out for lunch, we come back, we have our list. And it's much better than a developer sitting there for an hour, 2 hours, however long it takes to try and do this manually, and then also possibly missing something. And of course, developer adjustments. Whenever you do a big change like this, changing language, changing anything like this, there are adjustments to be had. You need to discuss any changes in coding style, tools, processes, all that kind of thing. When I was preparing for this talk, I went and looked through my emails and I found 2 extremely long email chains that were just all the information that we'd been writing up. We would have a discussion amongst our team, and then my team lead would sit down and he'd write it all up in an email, put it there, so we actually had it documented. And so this was the way we communicated it. You really need to be doing that as well, whether it's emails, whatever chat program you use, documentation, anything. Document the new build process, document the conversion process, document any gotchas that you find. If you run into problems and they're particularly tricky and it takes you a while to solve them, document them somewhere. Because if you're doing this kind of thing, you're probably going to hit them again. And I would also recommend actually scripting pre-commit or pre-build type checks to help the developers remember what to check. We haven't done pre-commit hooks ourselves, although we have been talking about it for a fair while. We once again have a problem where all our libraries are slightly different. But we do have, our npm test script in a lot of projects actually runs a bunch of other checks as well. So every time we run the tests, we're also running TSC, some of the projects run linting, they run a bunch of things in that. And that, again, has saved us quite a few times, because before you even get to making a PR, you've run all these checks, you don't have to remember them in your head, your script is doing it for you, and you don't have to worry about it. And this way you don't break the build when you make a PR and then it turns out that, oh, you missed like a white space or somewhere and your linter's yelling at you about it. All right, so continuing work. So we did do gradual typing, which means it is a continuing process. We still need to add more types. We've made a lot of progress. A lot of our code is rather heavily typed at this point, but there is always more to do, particularly in those libraries that we don't tend to touch very often. We also want to enable more compiler features. For example, that circular reference problem, we want to fix that at some point and turn that flag back on for that library so we can make sure that doesn't happen again. We also want to build a type definition file for TinyMCE's editor API. So TinyMCE is a project that is intended for developers to use in their own projects. It's more of a service than a standalone product. And we figure since we've just gone through all this effort of converting this to TypeScript, we'd really like to make it easier for people to put TinyMCE into TypeScript projects. The biggest thing we could do there would be to create a type definition file for the API, particularly since we've just been working on a new version of TinyMCE, TinyMCE 5, and we've actually changed up the API a bit in that. So for developers who are used to our product but might be moving to TinyMCE 5, they've got some new API stuff to deal with, this would help them a lot. Speaking of, TinyMCE is open source. If you would like to check it out, it is on GitHub. We have all our TS files there, and a lot of our config and build files, if you're interested in how we do any of this. Just a note, master branch is TinyMCE 4. There is a 5.x branch for 5, because it's not quite stable yet, but we're almost there. And if you do find a bug, which I'm not the best TypeScript person in my team, and I'm sure there's probably some people in this room who are better at TypeScript than me, particularly if you can find a TypeScript bug, please let us know. And if you want, we have a developer challenge and you can win some swag for it. So, thank you. All right. And I do seem to have gone, I have like 10 minutes until the session ends, so if anyone does have any questions. How do we get who, sorry?
The buy-in, like how did you convince
I think because we'd been talking about it for a fair while, I think everyone had an idea that it was something we wanted to do. And we pride ourselves on having very robust code, having a very robust product. And this was sort of just another step for us towards doing it. But also, like when we did TinyMCE 5, we actually rewrote the entire UI. And this was one of the things we kind of wanted to do that. We said that this would help us a lot with being able to do this rewrite, being able to, with making our own framework, someone made a UI framework, which he would hate me for saying this, but it's sort of React-like. And that has TypeScript in it, so it made sense to use TypeScript in the editor, all that kind of thing. So it was sort of a stepping stone of, we've been wanting to do this for a while, we've discovered gradual typing, here's this nice, easy way of doing it that won't take us out of commission for too long. Can we do this? And this is all the benefits the company will get from it. So, yep. I did actually think of that yesterday. It is currently only internal, but I can certainly ask about it. We do have a lot of open source libraries, so I can ask, see if Spocky will put it up on GitHub. Yeah, I feel like it probably is a little bit custom towards our old module framework, Bolt. But considering that framework was just a subset of the AMD spec, then it probably would work for most AMD to ES 2015 conversions. So yeah, I'll certainly ask. Cool. Yep. There were some things that we wanted to do sooner rather than later. So for example, in the most common dependency we have two libraries called Katamari and Sugar. Katamari is data types. Sugar is DOM manipulation, essentially. Those are used by almost every other library. And so we went, okay, these need to be the very first thing we type. And I think that was done only a couple of weeks after we'd done the initial conversion. And that was where we really sat down, like my team lead and the integrations guy who sat down and learnt TypeScript properly. They partially sat down to learn TypeScript so that they could actually do those. And those were almost fully typed from the beginning. And then when we started doing the TinyMCE UI rewrite, the intention was that would have types from the beginning. That is almost fully typed. Some of the newer code, we've been getting a little lax maybe, but definitely we said that anything that is very common to all our libraries, anything new from now onwards, those are as typed as we can possibly make them. And then we sort of prioritize by partially how commonly something was used as a dependency and how worried we were about a library. So some of the libraries are, like there's a library called Ego, which, we do a text editor, there's a mode in which the toolbar can float. Sort of like when you have web pages and the navigation always floats at the top and you can always see it. We have a similar thing for the toolbar. There's a library that is basically pure math for determining where that toolbar should be positioned. And we're not very worried about that one because it's pretty solid, it's just math. Like we have a bunch of tests in there, it's fine. But then we have other libraries which are more DOM manipulation or that kind of thing, text manipulation of varying kinds. Those we wanted to type because those are the ones that we were a bit worried about how robust they were. So, at the moment, we don't have any way to generate it as such. We would like to. That would be really nice. The way the code's structured at the moment, we can't really do that, so it would be a separate file that we would have to manually keep up to date. But we have actually been talking recently about how to move towards having something we could generate from. So we'll have to see how we go. We're definitely talking about it at the moment. We kind of just need to find the time and see what we can do. So, yep. Yeah, so I was saying before, yeah, I'll ask the devs in the company and see if we can release that. We'll probably just put it up on GitHub or something. I'm honestly not sure what. Knowing who wrote it, it probably was based purely off AST theory. It probably wasn't based off anything in existence. That was one of our Swedish devs, so unfortunately not my team. I wasn't too close to that. But yeah, I can certainly ask and see what we can put up about it. Cool. All right, any more questions? No? All right, thank you very much.